All right, so here is the second graphing tutorial where we are going to be going from D versus T graphs to V versus T graphs to A versus T graphs. So what I've got here are two of each kind set up. And so I'm going to do one with constant velocity. So I'm going to do one up here with constant velocity. So up above this line, this will be constant velocity. It's supposed to be a T up there. There we go. Constant velocity. And down below the line, we will be accelerating. Okay, so we're going to see the difference between the two as we go here. All right, so constant velocity, as you know, on a D versus T graph means we are covering the same amount of time in the same displacement, which gives us a steady slope there. Now, to get the V versus T graph, it is the slope of this value that gives us the Y value on the next graph. So whatever this slope is, let's say it's 3, would then give us the Y value on the V versus T graph at 3. Again, the same relationship exists when we go from V versus T to A versus T. The slope on the V versus T graph gives us the Y value on the A versus T graph. Well, the slope here is 0, meaning the Y value will be 0 for the acceleration. This is showing no acceleration. Again, this is a situation where the concepts agree with the graph, because at constant velocity, you should not be accelerating. And sure enough, that is what we end up with on the graph. The graph shows no acceleration, a 0 acceleration. Now, when we're accelerating, what we end up with now is we are changing our motion, which means we will cover a different distance in each interval of time, meaning our graph will no longer be straight, it will curve. So let's say it curves like so. Now, slightly more complicated, but not much. The slope of this value still gives us the Y value for the next graph. The thing is, now the slope is changing. So at the beginning, the slope is 0. So my initial value is 0. At the end, my slope is greater than 0. So at the end, my slope should be, or my Y value is greater than 0. Now it is constantly changing. That rate of change, believe it or not, is constant. And you just have to take my word for it for right now. But in our course, the only curved graph you will ever see will be a D versus T graph. So you'll never get a curved V versus T graph, so you don't have to worry about that. All right, so what we end up with here is a straight line V versus T graph that shows the velocity is increasing. This is what the D versus T graph shows too, because the slope initially indicates a slow object, and at the end indicates that it's moving faster. This is also what V versus T, because at the beginning we are moving very slow, and at the end we have a much higher velocity. Now, just like above, the slope of the V versus T graph also gives us the A versus T graph. So, but this time the slope is constant because that is a straight line. So the slope is the same the whole time. So that means the A value will be the same the whole time. We will get a consistent acceleration curve, and it will be the same value. Now, for our purposes, this is the only shape you will ever see on an acceleration graph. It will either be a flat line at the origin, like up here in constant velocity, or it will be a flat line at some place.